Hello. Okay, you should see the desktop, and I hope you can hear me. Does everything seem okay? Can you hear my voice?
Yes.
Okay, great, thank you. And let me see. Uh, okay, people are still coming in. There. Okay. Um, okay, so today is the test. Okay. So first let me say there's a little bit of instructions here. And what it is the exam will be right when as soon as we're done at 1:45, the exam will be available on Brightspace, the same page that you've been using for uploading homework assignments, programming assignments. Go to that page, and it's also in. It should be in your calendar, so you should be able to see it in a lot of ways in Brightspace. But the exam is there. Uh, oh, let me show you. Uh, darn it! Let me just show you what it looks like, so you know what to look for. You'll see a PDF document that looks like this. Okay, so the exam looks like this, and you'll download this, and there are instructions on the first page to tell you, yeah, basically saying that how you can do this. So, for example, you could print this out, and you could print this out and write your answers just like if it was a regular test. If you don't have a printer, you can just write your answers on blank sheets of paper, but I ask you to write your answers in the same order they are here. So do problems 1 and 2 on the first page. Do problem 3 on your second page. Do problem 4 on your third page, okay? So just write your answers on a blank sheet of paper. So that's the second way. You can either print this out, write your answers on this page. You could, if you can't print, you can use you could just use blank sheets of paper. And if you're good at Word or Google Docs or any other kind of document making system, you could create your answers in a Word document. Okay, and if you want, you could probably. It would be nice if you could cut and paste these problems into the Word document, make it a little bit easier for yourself to read it even. So, like you can copy and paste a problem from here into a Word document. I don't know if you can convert PDF documents into a Word document. Does anybody know, like, if you open this thing in PDF, can you save it or if you open this thing in Word, can you save it as a Word document? Anybody
No,
know?
I
Should
believe
be.
Pardon me? Anybody know?
you go.
Maybe not. Yeah. Um,
You might be able to
I
export it as a PDF.
no, it
yeah,
is.
Yeah,
I
there's
know
a conversion
what
process.
you're using right now. I believe Adobe Acrobat and stuff. If not, also like the computers at P&W also have Adobe on them. They're able to let you put
Oh,
text on the document
yeah. Or yeah. Oh,
for
that's
that.
another point. Yeah. You might be. Yeah. I don't know if that might be a crummy way to do it, but you might try writing on the PDF document. But I just thought, like, let me try this. Convert to Word. Add files to export. Export to Word. Well, it's sending me to some website.
Yeah, you usually got to pay.
Oh, that's absurd. Wow. I don't like Adobe. I've never quite really liked Adobe. Okay. And they want you to sign in. Okay. Yeah. So,
There's probably some free alternative somewhere we
yeah,
can
there might
get
be,
the
but
PDF
but
over.
but don't go overboard. I mean, that's yeah. I just thought that that occurred to me that might be a way to do it, but it doesn't seem like a very good. Okay, so um, copy and paste would probably just work a lot better. You can just do that. You know, you can just uh, copy and paste it. Okay, where is the copy? Is one of these copy? Highlight? Oh, you know what
I
works?
try
Oh,
why not
I
try
remember.
Control
No,
C?
let me show you a trick. Let me show you a trick. Adobe doesn't work. Adobe's not one of my favorite companies. Okay, and for good reason. Like, watch this. I've got this is my browser. This is Chrome. Okay. Open the PDF document in Chrome. You can do all kinds of stuff now. Like for example, now you can copy. See, Chrome doesn't have any problem about stuff because Adobe's trying to make you pay. Like we saw, they're trying to make you pay to do almost anything. So just open. You can open the PDF document in Chrome, and Chrome will let you, if you want to make a copy of the problem, see copy, and then you could, paste it into a Word. Then you could create a Word document. See, okay, something like that. What happened to the code? The code didn't come out very nicely. That's okay. Yeah, that's okay with me. Yeah, the code didn't come out very nice, but let me try something else. Create a text document. Open it in Notepad. Came out better. I pasted it into Notepad and as just a text document. Even Word, Microsoft's not one of my other favorite companies either. Sometimes simple things like Word documents work. So now if you take this and highlight it, now go back to the Word document. See, it pastes much better. You can play around. Playing around like this is good, especially if you're going to be if you're a computer science major and you want to get a job as a programmer. Learning to manipulate documents is really important. Notice right now I've got a Word document, a text document, and a PDF document. Okay, and I'm kind of like trying to figure out, which one of these is going to work best for me: the Word document, the PDF document, or the text document. Okay, we float between these a lot. Yeah, sometimes I actually will take. It's not uncommon for me to want to move something from one document to another kind of document, and I have to move it through a text document in between to make it work. Okay, so if you feel comfortable with all these different kinds of documents, you could try, whatever you think will actually work for you. Like I say, you can print this out, write your answers on the page, and then scan them back in. You could, if you can't print, you could write your answers on blank sheets of paper. Just write your answers with a paper and on a blank sheets of paper with a pen or a pencil. Okay, and if you want, you can try to create a document to turn in. Edit the PDF, though I think that I kind of doubt that that's going to work all that well. You might try it. You might be able to edit this PDF document. You could just create a Word document with your answers in it. If you want, you can try to copy the problems into the Word document. It looks like you can kind of do that. Okay. Google Docs might work better than Word. A lot of people nowadays, Google Docs are free, so you don't have to pay them. Like even Word, you have to pay for it. Okay. So if anything that you can, pretty much anything that you can make readable and nice looking is what your goal is. Make something that's nice looking. So if you write out by hand, write clearly, and like I say, put each problem on its own page. Make it so that you put, well, not each problem, but like those two problems on a page. Put that problem on a page, that problem on a page, those two problems on a page. It'll make it a lot easier for me to find your problems, and I can go through grade them much quicker. So put them in the right order, put them just like they are here. So okay, and I say that on the first page. That's pretty much what's written up here on the first page. About is it? Oh, and then when you scan it in, I put I don't know if you've got a scanning app on your cell phone, that's fine. If you're going to do the writing things out, I put a link here to a, just in case, there's the Adobe scanning program. Okay, and I also put a link to here's a Microsoft scanning program. Okay, again, not two of my favorite companies, but this Adobe scanning app does work. I've tried it. It works pretty well. I haven't tried this one. I don't know if anybody else has, but this one did work pretty well for me when I tried it. And this one seems to be pretty recommended. Okay, so if you don't have a scanning app on your phone, you could try one of those two. But if you create a Word document or something like that, you don't need a scanning app, because that's the nice thing about creating a Word document. You have something that you can keep on your computer, you have a nice record, and you can just upload it. It's a lot easier to upload it than the scanning thing. So if you are comfortable with using Word or Google Docs, that probably would be the nicest way to do your exam, is to create a exam document yourself that you can upload. Okay, now, other thing is, you'll download it from Brightspace right after class. It's due back at Brightspace at 11:30 this evening. Everybody's supposed to do their own work. This is not not like the review problems. I said, like I told you, the review problems, you can talk to people about them, ask me questions about them, but the exam you should do on your own, but you can ask me questions. So during the exam, while you're working on it today, if you're not sure what a problem's asking for, if you think there's something kind of fishy, if you think it's ambiguous, if you're not sure, send me an email. So you can ask me questions during the exam. Don't ask me if you got the right answer, and don't ask me how to do the problem. But if you have a question, you think you're afraid you're misinterpreting something, you think it's maybe not clear, please write. Especially if you think something's not clear, please write. Okay, so you can send me an email asking me questions while you're taking the exam, and you could ask for a meeting too. I have office hours right after this class, and so you can join the office hour, and also you can ask me to meet with you on Zoom if you have a detailed question. So do ask questions. Even when we had exams in the classroom, I always told students that during the exam you could ask questions. Like I always told students that you could come up and ask me a question during the exam, because a lot of times people would be, there would be people misreading a problem, or they'd find a mistake in my exam. Sometimes someone would find, oh, you didn't write, what you wrote here isn't clear. Okay, I think this exam doesn't have any mistakes in it, but I always think they don't have mistakes in them. But if you think something's funny, ask a question. Okay, so anybody got a question about the exam mechanics so far?
If someone does note like a problem with the exam, will you email us,
Oh,
send
yeah,
out
that's a good point. Yeah, I'll try. Yeah, that's a good point. If somebody finds something really wrong with the exam, I'll probably make an announcement. I can use Brightspace to send an email to everybody. Brightspace has got this little tool where I can send everybody in the class an email. So that, usually I would write that on the Blackboard. You're right. If there is really something wrong with the exam, I usually write it on the Blackboard. So if there is something that everybody should know, I'll send you an email by Brightspace. Okay. Hey, what are other questions about the mechanics of this?
Yeah, I have a question. So like when we upload it, is it going to be one file again? Like
Yes.
how we did before?
Yeah.
Okay.
I even restricted Brightspace so you only upload one file. So you can't send me 7 please don't try to send me 7 documents, 1 per page. Yeah, I want you to, to solve that problem of making it a single document. The scanning apps work pretty well with that. Or if you want, you could create your own Word document. But yeah, you can upload more than once. If you upload it and you go, oh darn it, I didn't do problem 2 right, you can upload it again. So you can upload the document more than once. Okay, so it's not a one-shot deal. So up until the time the exam is due, if you've uploaded it and you say, oh no, I can do that better, you can upload it again. But each upload is one document. You'll upload one document that should be 7 pages. Okay. Other questions? Okay. Well, okay. Let's go to the review problems. And you've been thinking about this stuff now, so now's a good time. Anybody got any last-minute questions about review problems we could work on? Anybody want to ask a question about one of these?
Yeah, could I ask about 18 and 19?
Sure. Let's see. So okay, all right. So now let's transfer this to Java Visualizer. So all these problems can be worked on in the Java Visualizer. So it's a nice tool. So let's just go over here to Java Visualizer and put this code in there and then start playing around with it. Okay, right. So here's the code in Java Visualizer. Okay. Now the question is, explain all the possible values that the variable w can have after the following code is executed. So w starts at 0. The question is, well, now notice that you don't have, there's these two variables u and v where you don't know what they are. You just know that they exist. Now over here, I can go ahead and put them in my code myself, okay? So I'll go ahead and put an int u equal something and an int v equal something, okay? But the question is, at the end here, for example, if I printed out w, what would I see out? What could w be at the end here? You don't know what u and v are, but what could w be at the end here? So now I'll start thinking. So now this still won't run yet because I didn't put values in here. But okay, so w starts out 0. What does this do?
If u is positive, we'll add 1 to w.
Okay, so if u is positive, you add 1 to w, so w becomes 1, but otherwise w stays 0. What does this do?
Same thing, but if v is positive.
Yeah, okay. So now think about it. What can w be when you get to the end here?
It's always positive, right?
It's always positive because it starts at 0, and the only thing you do is add to it.
So that could be 0, 1, or 2.
It can be 0, 1, or 2. Now, what do those numbers mean in this case? What is, if w is 0, how did it get that way? What does that tell you?
It tells you that u and v are 0.
Not quite.
Oh.
What's the yeah?
Are smaller than 0.
Smaller, they're negative or 0. See, what makes this thing increment is when you're above 0. So you skip this if you're 0 or negative. So this tells you what? If the final answer is 0, what do I know about this program?
U and v.
Nor v is positive.
Neither of these are positive. What if the final answer is 1? What do I know?
One of them's positive and not the other.
And what if the answer is 2?
They're both positive.
They're both. So what w is doing is it's counting how many positive values you have. W is counting how many of these guys are actually positive. Okay, so it's essentially a counter of how many positive numbers do you have here. You have either one of them, none of them are positive, one of them is positive, or 2 of them are positive. Now, if one of them is positive, you don't know which one, but it might not matter to you. You might just need to, this is a little bit of code that'll count, just tell you these 2 values that are important to you, it'll tell you that one of them is positive, or both of them is positive, or none. And then you can check, like make this -1 and make this 4. Okay. Now I got something that'll run. Okay. The w is 1 because I had one of these positive. See? Try making this -4. Okay. Visualize it. Go to the end. W is 0 because neither of those was positive. Okay. And then you can make, for example, both of them positive. Okay. Go to the end. W is 2 because it counted 2 positives. Okay. So now the problem said, explain all the possible values that the variable can have when this is executed. So your answer for this would be 0, 1, or 2. Those are all the possible values. Like w can't be 3. There's no way that w can be 3, and there's no way that w can be -1. The w can end up as, the answer is that w can end up being either 0, 1, or 2 because it's counting how many of these are positive numbers. So it's 0 when neither of them are positive. It's 1 when one of them is positive. and it's 2 when both of them are positive. So that's what the explain here would mean. Yeah, explain what this guy could, what W can end up as and why. Okay, now let's see. Let's do the same thing for this one. Okay, let's do something. So, let's go. Go ahead and put in the Java visualizer so we can have something to work with. Okay. Now notice that this one's got the same idea. There's a int u that I don't know what it is yet, and an int v that I don't really know what it is yet, but I'm supposed to think about what this code would do for any possible u and v. Okay, so it doesn't really matter what u and v are. I still want to say what this code does. So I'm really interested in, at the end, if I print it out, in this case, it's if I printed out the x, what would be in x? What could be in x? What could be in x when I get to this part of the program? So let's start. Let's just, we don't need to know what these values are. We can just reason our way through. So we start with 0. We only increment x. Okay, now there's 2 increments. So, we're kind of thinking, well, x is going to be 0, 1, or 2 maybe. Because just like over here, see that there was, you could add, oh, remember, I can't, does everybody remember what this thing here means? We only mentioned it a couple times in class real briefly. Does everybody remember what that means?
It increments the variable up.
It adds 1 to it. Here's 3 ways of writing that. You can write it as w plus plus. You can write it as w equals, you can write it as w is w plus 1. Or you could write it as, there's a third way to write it, w add equal to 1. We have 3 ways of writing this in Java. You can say increment w, or actually there's a 4th way. You can write it as plus plus w. All of these do the same thing. Increment w by 1, add 1 to w and put the result in w. This just says the same thing. Add 1 to w and put the result back in w. It's a very funny way to write it, but it's saying add the 1 and set the result back equal to w. So it's another way of writing this. And you can also put the plus plus in front of the w. Okay, so this means add 1 to the variable. Okay, all right. Now notice that there were 2 increments. So w couldn't end up being 3. It starts out at 0. It can't end up 3 because there's not enough increments to do that. Okay, here we have the same 2 increments, but let's see. It may or may not be that the answer is 0, 1, or 2. Okay, so if u is positive, just like before, count it. But what if u is not positive?
Checks if v is positive.
It checks if v is positive. So now let's think of all the cases. If u is positive, add 1, but then what's the next step?
Just print x.
Print, okay, that'll be 1, okay? So if u is positive, add 1 to x, go to here. What if u is negative?
Check for V.
Check for v. If v is positive, add 1 and then print it. What if v is negative?
Nothing.
Well, not nothing. What's next?
Just print X.
Just print. Okay. So now, how many increments could I have?
3.
Where would I get 3?
It would only be 2 total, right?
How do I get 2?
I would say 1.
Pardon me?
0 and 1.
Increments, just 1.
Just 1. Because think
Oh.
of the cases. Think of how you can flow through this code. If this is true, you do that and you're done. That was 1 increment. If this is false, you go here. No increment yet. If this is false, you don't do that increment, you go here. If this is true, you do that. That's one increment. But if this is false, no increment. So how many increments can there be?
1.
At most one, right? So how many could there be?
0 or 1.
0 or 1 increment. So the answer here is 0 or 1. Unlike over here, we could get two. See, over here, we could get 2 increments because these were independent ifs. This one, they're not independent. See, this if is in an else. So you only get to this increment if this one was false. So you can only do one of those, at most one of those increments. Now think about it. What does 0 mean here? Okay, over here, 0 meant neither of the numbers are positive. This meant that one of them was positive. This meant that both of them are positive. Okay, what does 0 mean here?
Neither are positive.
Neither are positive, just like before. What does 1 mean here?
At least one of you or V is positive.
It means the same thing it meant over here. It means that one of them is positive, but you don't know which one. It means that one of them is positive, but there's no 2 in this case. This one just tells you none of them, neither of them positive, or one of them is positive. This one counted the number of positives. There's either 0 of them positive, one of them is positive, or 2 of them are positive. This one gives you a little less information. It tells you neither of them is positive, or one of them, but you don't know which one is positive. Okay, so the answer here is 0 or 1. Okay, because even though you see 2 increments, because they're nested in ifs, you can't do both of them. So you can only do one or the other. So at most, you do one of the increments. Okay, so the answer here was 0 or 1, and the 0 and 1 mean the same thing here that they did in this example. 0 means neither of them is positive. 1 means one of them is positive, but you don't know which one, and there is no 2 here because it doesn't count how many positives there are. It just tells you neither of them is positive or one of them is positive. A little chunk of code like this is actually useful. This eventually you'll see that you do these kinds of things. You need to sometimes you'll have numbers, and you just have to know whether one of them is positive or neither of them is positive, or maybe you need to know that how many of them are positive. These are little chunks of code that you end up seeing in larger programs. So these little chunks of code do something. Okay, so that little chunk of code actually, we say it does a calculation. It actually calculates something for us. The W's got an answer in it. Usually I would use a better variable name than W. If this was a real program, I would give W a name that gave me a sense of what I'm counting. Like, I mean, if this was a program, I would say that variable is the number of positives. Okay, so I mean, I would try to make it readable. If I was, in this case, I wanted it not to be readable. In this case, it was actually meant to not be too readable using generic variable names. So you had to think real hard about the logic. But that's what programmers want very good variable names for. Good variable names are supposed to help you not have to think so much about the logic. So if you make it like this, you're helping someone a lot by doing that. If U is positive, you count the number of you add 1 to the number of positives. If Z is positive, you add 1 to the number of positives. Then you print out the number of positives. Okay, so real programmers would try to help people understand their code by using good variable names. For practice here, I used very generic variable names to make you think hard about the logic. So you had to think hard. Now, programmers still have to think hard about the logic because people make mistakes. So just because somebody claims that that's what it holds, you have to check the logic to make sure it really does hold what they claim it holds. Okay, so like over here, if I called this guy the same name, I would be wrong. Now, this one is not the number of positives. This one just is, I don't even know what would be a good name. Maybe what would be a good name for here? It's 0 if there's no positives, 1 if there is a positive. It's not the number of positives. What would be a good name? See, that's what program, what would be a good name for this? Not the number of positives. What might be a good name?
Is positive?
Uh,
Numpos.
Is least number of positives good?
is positives, because yeah, is there a positive or not? That's not so bad. Is positive. There, yeah, if it's 0, that would say no, there isn't a positive. If they're 1, there is a positive. So that'd be, is in a variable name is a good way when you're measuring something that's 0 or 1 or true or false. So is positives, has positives, you have a positive number or not, what was another suggestion?
Least number of positives, because if
Yeah,
X is 1, there could be 1 or 2 positives.
yeah. So that's the least number of positives. Yeah. Now let's get now notice the name's starting to get kind of long, but that's very descriptive. The least number of positives, because if it's 0, you have 0 positive. If it's 1, you have at least 1 of them positive. So that's not bad. Let me show you a little thing. Google. There's an old saying that there's only 2 hard problems in computer science. Okay. The only 2 hard problems in computer science are cache invalidation, which you'll learn about someday, and naming things. This is a real famous quote. There's only 2 hard things in all of computer science. This thing called cache invalidation, and the joke is naming things is the other hard problem. And it's true. Naming things is really hard. Coming up with good names is actually way trickier than anyone would believe. So this is an old, it's kind of a joke, but it's actually, it's a bit of a piece of wisdom. Cache invalidation turns out to be something very, very hard. That's a real serious, deep computer science problem. This doesn't sound like it would be hard, but it is. Naming things. Okay. So, here you can see, come up, no, don't call it X. That's completely unhelpful. But then on the other hand, trying to come up with a good name is not so tricky. If you do it, if you go overboard, you end up with names that some people would think are too long. And if you leave it X, nobody knows what you're talking about. Right? So you have to come up with good names. Good names help people read your code, but they don't solve the problem because somebody still has to check your logic. Just because you claim that this is the number of positives doesn't mean that you got the logic right. So you got to make sure you still have to check people's logic to see that they're doing right. Okay, so that's how you would do these kind of problems. You essentially, in your head, you keep track of what's going on here. And then sometimes you might want to make a little table, or you have to find a way to keep track of the possibilities. Like, what could you be? You could be positive or negative. What could V be? V could be positive, negative. Sometimes with these problems, you need to keep a little table or a little list of possible values. Okay. All right. So now, what about another problem from here? Anybody got another question about a problem from here?
Yes, can we check 16 and 20, please?
16?
Yeah.
Okay, so, all right. Now, for 16, back to the Java Visualizer. So let me copy this. See, the problem's asking for a memory diagram, but the Java Visualizer is great at doing those. Okay, so punch the code into the Java Visualizer. Now, to get memory diagrams of strings in Java Visualizers, you have to, I think this is terrible of them, but they make you choose to get proper pictures. Otherwise, they give you like what they think is a easier to read picture. But easier to read is not helpful here, because if it's wrong, it's wrong. I don't know why they thought that was a good idea. So you have to remember to click this little button, show string, not just values. Okay, so if you, I'll show you in a minute what you get. Otherwise, you don't get a very helpful picture. Okay, so go under option and click that button. All right. Now, this will draw us our memory diagram. Oh, let's see. What did I do wrong? Did I
The
misspell
C
something?
there might need to be capitalized. I don't know. Or
Oh,
maybe-
yeah. Yeah, there. That was a misprint.
or should it also be salutation equals salutation dot two uppercase?
Ah, that's the, no, I didn't do that on purpose. Yeah. So you have to yeah, that's the kind of thing on an exam that would be, did he really mean it that way or not? Did he really mean it that way? And the answer is yes, I really meant it that way. And we want to see what that means. So I really meant it that way. Okay. And I did have a misprint. I did have, that was supposed to be, which problem were we on? No, that was supposed to be a capital C right there. Okay, that was supposed to be a capital C. And see, it was a capital C there. Okay, all right. So now go over to the visualizer and watch it. Remember, it's going to draw the memory diagram over here. It's going to draw a variable on the left, objects on the right, connecting them with arrows. And that's what you have to do on the exam. If it asks for a memory diagram, you're going to draw things like the Java visualizer does. Variables on the left, objects on the right. So for example, this creates a string variable. See, that's the box. The variable is the box. The string variable is called salutation. And there's a string object, and that variable refers to that object. Okay. Now here's the part that's a little bit tricky, the questioning. What does 5 do? You tell me, again, what does, the way it's written, what does 5 do?
It counts from G to T. It actually takes letters from G to T.
I'm not sure what's G. I'm not sure. I mean, from this G to that T?
Yeah, without
What?
T.
Pardon me?
Without T.
Why would it do that?
Why would it do what?
Why would it go from the G to the T when you say two uppercase?
He's referring to the next line of code. He misunderstood you.
Oh, yeah, I'm talking about line 5. Oh, you're right. Yeah, that's like, yeah, what you're describing is line 6. No, what does line 5? See, we're about to do line 5.
Oh,
What
It uppercases everything.
Okay, it takes everything, but where does it do that?
It doesn't do anything, does it?
It does do something. It's a line of code. Yeah, so every line of code does do something. And that's one of the things, we want to make sure we know exactly what every line of code does. It does something.
It just
You're
doesn't
right, we
store
won't
it
see
anywhere.
it. What does it do?
I said it just doesn't store it anywhere.
Doesn't store what anywhere?
Uppercase.
It takes all the letters in this string and does what with them?
Capitalizes them.
Capitalizes them, but where? Right there? We mentioned this in class before. What do strings?
Oh, from R to the end because the G is already capitalized.
Yeah, but where does it put the capital letters? Does it put them on top of these guys?
Doesn't it just make a, it doesn't make a new object, does it?
Yes, it does.
Okay.
Yeah, that's what we said in class. It actually puts the capital letters in a new object, which is going to sit over here. All right. But here's what's wrong. But it does. So it puts the uppercase letters in a new object. But somebody mentioned it before. But what's wrong?
No arrow is going to be drawn to it.
No arrow is going to be drawn to it. We didn't save it. We didn't print it. So we lose it. If you don't use it, you lose it. Java's like that. If you don't somehow either use the string or make an arrow to it, it just disappears from memory. It actually, if you were watching the computer super fast for about a millionth of a second, there's a capital greeting in there, and then it just disappears. It gets created and then disappears. So what happens now if I execute 5, nothing happened. It looked like nothing happened. Okay, so I did not make those letters uppercase. I made a copy of greeting uppercase, but I didn't make a name for it. Now, if I wanted to, I can go back here and like what somebody said, I can say string, I'll call it S5 equal. Now, if I go here, but this isn't what the problem is asking, but now you'll see here. See, now I see that, but I need a name for it. See, it's a separate object, and I got to give it a name. Otherwise, I lose it. Okay? So, real important. 2 uppercase, and all string methods are like this. They do not act on the data in this string. Well, I'm sorry. They act on the data in the string, but they make a copy first. So, they act on the data in this, they act on a copy of the data in this string. So that'd be the good way to put it. All string methods act on a copy of the data. If you don't save a reference to the copy, you lose it. Okay, so the original problem was like that, with no name. Okay. So let's keep looking at the string of the memory diagram. So we've got the first step of the memory diagram is there's a string named salutation. Okay. Now, what's the next step of the memory? What am I going to see over here next?
S2 pointing to greet.
Yeah. So I'll see another box. I'll see another string variable. That string variable is named S2, and it points to the result of that substring, which is from 0 to 5 in this guy. And what I'm looking for is you don't have GREET all capitalized, because if you misread this, you might think that this is all capitals. That's a mistake. Yeah, that was what this was supposed to catch, would be that at this point, you would think that by the time you got to line 6, you might think that everything in salutation was all caps, but that's not what this guy does, okay? So S2 is GREET, because S2 is actually still working on this version of salutation. Now, what's the next line of code do? What do I get after line 7?
S3 pointing to greetings in lowercase.
Yeah, S2 to greet. Because see which one?
Oh, yeah.
In lowercase S2, not salutation. So it lowercase greet to GREET lowercase. And I had to, if I didn't store that in the result, I would lose it. Okay, now here's a tricky part. What is this thing? What do you think this thing's going to do? Analyze it step by step. What does that do for sure?
Creates a new variable.
Creates a string variable over here. So we get a string variable named S4. The question is, what does it point at? So we get a string variable over here named S4. What does it point at?
Gonna put both of those strings together.
So what would it would point at? 1, 2, 3, a 4th string. We're building a 4th string, and what's in that 4th string?
Greet. The first one's capital G.
Yeah, greet, no space between them, and it's the capital greet in front of the lowercase greet. So there, greet. Okay, so there's the memory diagram. There's what the answer to the problem is. This picture. On the left are the boxes for each variable with the name of the variable, and in the boxes are arrows pointing to the objects. Now, let me add one thing to this code just to show you what. Now, suppose I had something like this. I'm going to add something to the memory diagram that's a little bit different. N is an int, so it's not a object variable. These are all string object variables. So what's different about what's going to appear over here now?
The number of characters in S4.
Yeah. So how would you tell somebody in words exactly what are they going to see in the memory diagram after I click the forward one more time?
The length of greet.
Yeah, which is what?
10.
10. Where will that, okay, there'll be a number 10 somewhere. Where's 10 going to be in the picture?
The object.
No. Where is it going to be in the picture? Think about it. So what's this guy do? Just that highlighted part.
Stores it.
Pardon me?
Stores it as an integer.
Well, okay, so the highlighted part here does what? That bit of code does what?
It's a variable.
It's a variable. So it creates a box over here. It creates a box. What's the name of the box?
N.
N. What's in the box?
Length
Number
of S4. which
Well,
would be
at this
10.
point, nothing is in the box yet. Then this is going to put what in the box?
10.
10. So I'll see a box. See, now notice that's how you should draw memory diagrams. This is what we mean by this is a primitive data type. The primitive data types hold their value in the box. The object type, the object variables hold an arrow in their box. Okay, so object variables hold an arrow to an object. Primitive variables hold a value in. Okay, let me give you another example of a primitive variable.
I have a question.
Uh-huh.
So in line 5, you said that the salutation to uppercase, it creates a new object, right, but not a variable.
Yes. Yeah.
So when we're drawing the Java diagram, are we gonna put
No.
the capital greetings in the
No.
object?
This would be the answer.
Okay. All right.
So this line doesn't even show up in your answer.
Okay. That makes sense.
Yeah, that's a good question. This would not show up in your answer because it's asking for the memory diagram, and this one doesn't affect the memory diagram. Without the name, it doesn't affect the memory diagram. Okay, so you wouldn't somehow do anything over here to say that what line 5 did because it did not affect the memory diagram. If somebody asked you what did line 5 do, your answer would be in words, it created an object holding all the uppercase letters of greetings, but then that object disappeared. You know, that's what you would say in words, but you can't draw that in this picture. Okay, so that's a good question. All right, now let's do another primitive variable. Okay. Oh, what did I do wrong? Oh, I didn't say, what did I do wrong?
You didn't say what string you want to get the character
I
from.
called a method, but I didn't say who I'm calling it on. I forgot to say who to call it on. So I'll call it on S4 again. Okay. So I want to know the 4th character in S4. The 5th character in S4. Okay. Now that's another primitive data type. The 5th character was a. Okay. Now let me do another example of a primitive. Starts with, asks the question, does this string start with that string? The answer is no. So I'll get another primitive variable to see how the value's stored right there. These aren't arrows. These are int, char, boolean, double are primitive variables. They hold their value right in the box with the name. So the variable is the box. It's got that name, and it's holding, in this case, 10. The variable is that box. It is called C, and it holds the character T. And the variable is that box. It's called B, and it holds either true or false because it's a Boolean variable. Okay. So your memory diagram should always look like this. The left-hand side are variables. Each variable is a little box. If they're primitive variables, they hold numbers and they hold things in them. If they're what we call reference variables or object variables, they hold arrows to the other side of the picture where the objects are. When you learn more about computers, you'll learn that these are actually two pieces. The memory in your computer is divided into 2 sections, what's called the stack and the heap. So the fancy name for here is this is called the stack, and this is called the heap. And your memory is divided in these two regions, and that's how the computer, that's part of how the whole thing works. But this picture is very, it's in that sense, it's very concrete. This really is what's in your computer memory. Java, C++, C, all these JavaScript, all these languages work this way. You have these memory diagrams that are the variables on the left, which are in something called the stack, and the objects on the right, which are in something called the heap. Okay, all right. Okay, so that's a memory diagram. Now notice that Java Visualizer does a very good job of it, and your answers, when exam asks for a memory diagram, you should model them on this style here. Okay, little boxes on the left, objects on the right. Make sure your box has a name. Every box should have a name, and either put an arrow to an object in it, or and let me show you one more example. Let me do one more example. Let's create a string variable, S5, make it equal to S2. Does that create a new string?
Yes.
No.
Okay, we got a yes and a no. And you're both right. Okay, so yes and no are both right.
It just creates a new string with a value of S2, the
Okay.
one that we already have.
Okay, you can say it a little bit better than that. When we go over to the pictures, there's a left side and a right side. Okay, now think in your mind, there's a left side of the picture and the right side of the picture. What's on the left side of the picture? I'm purposely not going to the picture. Think, what was on the left side of the pictures?
S5.
Well, in general, what's on the left
the-
side of a memory diagram?
The variables.
The variable. What's on the right side of the memory diagram?
Objects.
Objects.
What does line 12 create? It
It's gonna
creates
Variable.
a string variable, but it doesn't create what?
An object. Doesn't create
String
an object.
object. So the answer was yes. If both people were right. I said, does it create, I said, does it create another string? The answer is yes, it creates a string variable. No, it doesn't create a string object, because the string variable points to another string object. So the answer is line 12 creates a string variable, but not a string object. So let's go over and look at it. Notice that we're really precise when we talk about things in programming. If I ask you, does line 12 create a new string? You really should say, well, what do you mean? String variable or string object? Or your answer is, go down here. Okay, now let's see what this line 12 does. It's going to create a string variable. No new string object. There's still just 1, 2, 3, 4 string objects. That variable points to that object. See, make sure you really understand that. That's one of the most important ideas in all of programming. It's called an alias or a pointer. I've got two things pointing at that object. I've got two references. C++ programmers call them pointers. They literally call these guys pointers because they point at things. Java people don't like to call them pointers. In Java, they're called references. This thing refers to that. I just usually call them arrows. Okay? That line created a variable that shows up on the left side, but then it copied the arrow from this guy into that guy. Okay? Like, here's another example of copying. What does line 13 do?
Creates a new int variable.
Okay, on the left side, it creates an int variable. That's a box. What goes in the box?
The same object that n has.
Well, the same. It's not an object. It would, yeah. So if you use the word object, it's kind of confusing because object now means things like strings and turtles. So what does it put in K?
The same primitive value as n.
Yeah, the same integer in this case. It's an so since we know it's an int, it copies the value from that int. It copies what's in that int into that int. So you're copying from that int into that int. So that's an example of now notice that this copied arrows, this copies integers. Okay, now I'm about to create K. And K holds a copy of what's in N. Okay, it's a copy of what's in N. Okay, right? So this copied arrows, this copied ints. Yeah, so S5 is a copy of the arrow. See, essentially, the arrow that went to here, when it gets copied into here, looks like that same, looks like that arrow. We literally think of it as copying the arrow. This arrow, when it's copied into S5, becomes that arrow, and it really is pointing to the same thing. Okay. Computers have a hard time drawing arrows in memory. There really aren't arrows in memory. What there are what we call addresses. So that makes a little bit more sense ultimately, but we draw them as arrows. But what really goes in these boxes are something called addresses, is what you learn about in next year in the computer architecture class. You learn what actually, when these things are arrows, you learn what's really in those boxes. They're called addresses. Okay, but that copies arrows because this is an object variable. That copies integers because these are integer variables. Okay, all right. So that's beating that problem to death. Okay, what about another one?
Number 20.
Which one?
20.
20. Okay. Okay. Go ahead and copy this into the Java visualizer. See what. Now that's a method, so I'm going to copy it outside. See, I have two methods now in my program. I have the public static void main, which is still empty, and I have this method that we're asking a question about. Okay, now the problem says that there's, whoops, I don't want. The problem says that contains a single error. Okay, describe the error and show how to fix it. Well, let's let Java Visualizer tell us what it thinks. Missing a return statement. Okay, this method is supposed to give us an answer. So this takes in a number and it gives us back an answer of some kind. And then if we look at the code, we see that if the number is strictly positive, we return one kind of answer. And if the number is strictly negative, we return a different answer. Now, can anybody see why they would say there's a missing return statement? Does anybody see? Okay, let me say it again. If the number that comes in is strictly positive, here's what the answer is. And if the number that comes in is strictly negative, here's what the answer is.
It doesn't say what to do if it's 0.
Yeah, that's what they meant by missing return. It didn't say what to do if the n is 0. So what you really need is you need something like this. You need to say else. See, there's a third case. Strictly greater than 0, strictly less than 0, else, well, return, the right answer is return 0. If the input's 0, because what this is asking for is what's the last digit of your number. So if this is the number 15, the last digit's 5. If this is the number 1027, the last digit's 7. So this thing computes that last digit. But you actually don't even have to realize that that's what it's doing. The key was that you look at the code and see, well, it gave an answer when you had strictly positive, and it gave an answer when there was strictly negative. So you have to fix it by saying, well, I have to tell you what to do in this case. Now Java is happy. Now I don't, okay. And then if I go back, I can test it. Int x equal find last digit of 1,237. Go through the code, see, 7. The last digit of 1,237 was 7. So that's what it did. So that was the problem, that you can kind of, you know, it said what to do when n is positive, what to do when n is negative, and it didn't say what to do otherwise. It was missing the otherwise. And to fix it, you could just do you could return, you know, you actually, I wouldn't care if you returned 100 here. That wouldn't be the right thing for the function to do, but the problem just asked, how could you fix it? And the way you fixed it was essentially filling in that blank. It knew what to do for positive numbers, it knew what to do with negative numbers, and you have to say, well, there's an otherwise case. What to do in the otherwise case, which was, well, we'll just return a number here. And the right answer is return 0, but actually from this point of view of this problem, I actually didn't say that you had to make it correct. You just had to, well, it said fix it. So if you fix it so it compiles, it doesn't matter what you return. If you fix it so that it gives you the right answer was return 0. Okay. Okay. So that was that one. Any other problem?
22.
Okay. This is asking you to write a complete definition. So that means you have to write something that looks like this, you know, with a actually, this should be public. It doesn't really matter. Usually we make these things public. Okay? So I'm supposed to write something. Public, static. Okay. Now, what goes here is what the return should be. What kind of answer does the function give? Now, the function was supposed to be close enough. Okay. Okay. Now, go here. See, now it returns either false or true. So you can see that sometimes the answer is false, sometimes the answer is true. So that means over here that it returns Boolean. Okay. Public static Boolean. Now we need to know what does the function take in? It takes in a double and an int. So I write that as the input here, double. And I can make up my own name here. So I'll just call it x and int, and I'll call it n. I have to come up with my own names for those variables. Okay, so there's what I'm supposed to write. This function close enough, which takes in a double and an int and gives me back a yes or no answer. Then here's where the code's going to go. Okay, the code's going to go in there. Okay, now what does this function do? This is modeled off of a coding bat style problem. See, I wrote this in the same way coding bat would write it. So close enough. If it take, okay, they tell you here's the description in words. Okay, that takes in a double and integer and returns true if the double is within 1 unit on the number line of the integer. So the question is, how far apart are these on the number line? If they're less than 1 unit apart on the number line, return true. If they're more than 1 unit apart on the number line, return false. Okay, so it's a question about a little math problem. How far apart are numbers on the number line? Okay. How do you tell how far apart numbers are in a number line? If I give you, in this case, an x and an n, actually make this y, so make it x and a y. If I give you an x and a y, how do you tell how far apart they are in the number line?
Subtracting.
Pardon me?
Subtracting.
Say again? I can't.
Absolute value of x minus y.
Well, okay, yeah. The main thing you need is x minus y. Subtraction tells you how far apart they are. But we don't know which one is the larger of the two. So x minus y could end up being positive or could being negative. But what we really care about is how big x minus y is. So we need the absolute value. And that's absolute value is in the math class. So that's what I need. Math.absolute value of x minus y. Okay, that measures how far apart these numbers are. I'm interested in whether that is less than or equal to 1. Okay, so because return true if the double is within 1 unit of the integer. Okay, so I'm supposed to check, is the absolute value of x minus y less than or equal to 1? That's my answer. There's my function. Return this answer. Is the absolute value of x minus 1 less than x minus y less than 1? Yeah, see, is the absolute value of x minus y less than or equal to 1? Okay, that returns, now you can visual, see, it compiled. Now let me go back and let me call the 3 test cases. So up here in main, there's my 3 test cases. Okay. Now let's see if we get the right answers. This one's supposed to give true. But how do I know? Well, if I run this, is it going to help me know if I got the right answers or not? The little trick question. Is this going to help me know if I got the right answer here, the right answer here, and the right answer here? There's something wrong here. So let me see where's the answer going?
Nope.
I call that method. I give it those numbers. I get back an answer. What happens to the answer?
It doesn't get stored anywhere.
It doesn't get stored, and it doesn't get what? What are 2 ways to see an answer?
Printed.
Print it or
Stored.
store it. Print it or store it. The only way to see an answer is you either print it or you store it. Since I don't do either, watch what happens. See, I'm going to go all the way to the end. What happened to my answers? I never saw them. See, I didn't save them or print. I could either save them in a variable, so they'd show up over here, or I could print them so they would show up in the output box, which would be down here. Okay, I didn't save them and I didn't store them, so I can fix that real easily. Saving them is probably a little bit easier, so I'll say Boolean answer equal, and then answer equal, answer equal. Now here I'm going to use the same variable to hold 3 answers. So I'll keep overwriting the previous answer with a new answer. If I wanted to, I could create 3 variables and hold 3 different answers. In this case, I'm going to create 1 variable and hold the 3 answers in that variable and keep overriding it. Okay, now step through. Okay, first answer was false. That's what it should have been. See, false. Oop. Second answer was true. See, I've just finished that line. So second answer was true. Now I'm about to do this one. And the third answer was true. So I got false, true, true. Now, if you want, you could store it in 3 variables. So you could see answer 1, answer 2, answer 3. But here I just kind of said, I took a shortcut and just put it in 1. Okay. So notice that Java Visualizer can help you do a lot of this stuff. You know, you can do everything in Java Visualizer. It lets you see your answers right away. Okay. So in this case, this was a very much a coding bat style homework problem. Yeah, coding bat tells you what to do and gives you what the answers should be, and then you have to write the code. Okay. The only thing I should probably, the only thing to admit, what I didn't do that coding bat does do, when you do these on coding bat, they give you this part here. I probably should have done that. I should have remembered. The coding bat gives you that part, and what then they do is leave this empty inside. So in coding bat, they leave it empty in here, but they give you that part there. I realize I should have done that. I should have given you what coding bat gives you, this part here. Okay, then you have to fill in what goes inside here, just like a coding bat problem. Okay, you have to write what goes in here to compute the right answer. Okay, and in this case, it was just that one line. Actually, it was just one line to do that. I want to know if the absolute value of the distance between the two numbers is less than 1. Okay, all right. Got a few minutes left. How about another question? Yeah.
I actually have one question. It's from the first problem, number 1. It's F. Class names must begin with an uppercase letter.
Yeah.
Okay. I forget if that's enforced or not.
Well, that's what. Yeah. It turns out that's not enforced. We can actually Java Visualizer. Okay. If everything enforced would be enforced by Java Visualizer. So let's go over here and ask, does Java Visualizer care if that's a capital C or not? Hey, it didn't care. See?
Okay.
It didn't care. Yeah, and you know, you can actually, your Java Visualizer obeys all the rules of Java. So if you change that to, you know, now let's see. Suppose I put a space in the name. Well, Java Visualizer didn't like that. Can you hyphenate names? Take a guess. Are hyphenated names allowed in Java?
Yes.
Not in that instance, because you started with the word class, which is a restricted word.
Mm.
You're right. I couldn't start with a restricted word. Well, okay. What about that?
I think that's fine.
Anybody have another opinion?
I don't think they are, because that's why we use camel case.
No, no. Java doesn't care about camel case. We use camel case because we like it. Java couldn't care less about it. There's something that Java can get confused by here.
I think it's this dash.
Yeah. So what? Let me go down. Let me go down here. Suppose I have a variable name. Int my x. Is that a good name? X hyphen y to represent x minus y.
I don't think so.
I think it can.
No, it cannot tell the hyphen from the subtraction. Java will not let you hyphenate names because it can't tell the difference between hyphenated names and subtraction. It can't. It actually gets completely. It does not know how to tell this apart from this. This was, I hoped, a hyphenated name. This is x minus y. Java can't tell them apart. So it didn't like that name. And it didn't like that name either. Now, hyphenated names are kind of nice. What do you think you do in Java to get something like a hyphenated name? This is what you would use as an alternative to camel case.
Underscore?
Underscore, yeah. Underscore is the right thing to do. And some people prefer that to camel case. Okay. So that's allowed. Oh, let's see, what did I do wrong? Oh, I don't have a y variable. Okay, x minus n. I have an x and an n. No, let's see. Oh, no, I don't have an x either. What I was using k and n. My two integers in this case are k and n. So k, okay. Okay, so no, the name k underscore n is fine. This means k minus n. Do you see why we put the spaces around the operators? Because you're told that it's a good idea to put spaces around the operators just so that you don't start reading these things as hyphenated and stuff like that. Like that's a little bit kind of hard for us to read because we're used to hyphenated things. So put spaces around it. Okay. You don't put spaces here because that would break the name. Okay. Java doesn't allow hyphenated names, but it does allow underscored names. Okay. That's an allowed thing. Now, camel case is not required in JavaScript. It's just C programmers like these kind of names. Java programmers prefer these kind of names for no good reason. They just do. A C programmer would more likely write that would be C. That's what a C programmer would probably write. Bob name here. And Java people would write Bob name here, except if it's a class, then you would write Bob name here like that, all caps. All right. Okay, what about other ones from these up here? So that was not required. That's a choice, not enforced. Any question about any of the other ones? Okay, well we actually we've reached the end of the time. So the exam should be available at this point. It's 1:47, so the exam should be available. So get it. If you have time to start it now, you can start working on it now. You have till 11:30 this evening to finish it, to upload it. And like I said before, if you have questions, especially if you think something's a little bit funny, send me an email. And I have office hours soon after this. So I'll be in office hours. Anybody have any last question before we quit? Okay, so I'll stop sharing. Good luck. Remember, everybody's supposed to work on the exam themselves. You work on the exam yourself, but you can ask me questions and just have everything uploaded by this evening. Okay. See you. Well, we'll meet again on Monday. So I'll end the meeting now. Bye bye.
Have a nice day.
Thanks. Bye.